Welcome to SQL Malibu. Today we have a presentation by Tracy Boggiano about Query Store Primer. Tracy, it's all yours. Thank you for presenting for SQL Malibu.
All right, I'm going to share the screen that actually shows full screen. All right, so we're going to talk about Query Store tonight. This is my session on Query Store Primer. Who I am, I'm Tracy Boggiano. I'm the database superhero at ChannelAdvisor. That really is my job title. I know it seems unusual, but they like to call me that, and it's because of all the stuff that I do. I'm the co-leader of an advanced DBA group out of the Raleigh area, so I'm always looking for some advanced DBA topics. We do a lot of remote presentations. Level 300 and above would be what we consider advanced on the Summit speaking circuit, so I'm always looking for speakers for that. I started a website back at the end of February called WeSpeakLinux.com to help Windows people learn how to speak Linux. That includes me because I don't speak Linux. I'm learning. I'm also getting, as I was talking earlier, about getting Linux content into the past virtual chapters so that we all can learn how to run SQL on Linux, because I'm hoping that it'll eventually catch on and it'll be, 50-50 at some point in the next 10 years or so, maybe 5. But I'm also a member of SpeakingMentors.com, which is a website to help people get started in speaking. So if you're looking to get into the speaking world and need someone to help you there's a website of about 50 or so, mostly MVPs in the community that are looking to help people get started on their speaking careers. So if you're looking to get started on that, there's a place where you can go to pick you up a mentor that'll help you with that. On my spare time, which you all know I have now, I volunteer as a foster care child advocate in a program called the Guardian Ad Litem here in North Carolina. It's called different things in different states. I've seen one person was from Virginia, I believe it's Guardian Ad Litem there as well. I think in California it's called CASA. But it takes about 8 to 10 hours of your time a month per case that you have. I try to talk people into doing it. If they're interested, they can always message me after the session. There goes my contact information down at the bottom. It's the easiest thing to remember is databasesuperhero.com. There's an email link right there on my website with a link to my Twitter and my email, so I'm very reachable. So enough about me. Now on to what we're going to talk about. So first we're going to talk about what Query Store is, then we'll talk about how to set it up, what usage scenarios that you will use it for, which we've already discussed that starting this session. We'll talk about a few extended events that you might want to take a look at when you're troubleshooting some things or just to keep an eye on things, and some best practices around setting it up and maintaining it. And then we'll just sum everything up and see if there's any questions. And I will take questions as we go along. I'll try to keep an eye on the chat window, and Steve will interrupt me if there's any more. So basically, I like to say what Query Store can buy us, but I put what Query Store can do for us because, it kind of sounds cheesy to say buy. But queries, one of the main things that you can do for us is we can fix our queries that have regressed in performance. So if a query has had some parameter sniffing that has happened, and you've noticed that it's all of a sudden you've got a different plan, and it's regressed in performance, you can go in there and you can pick the plan that has regressed in performance and pick a better plan and say, hey, I want this plan to always be the one that it runs. You can also use it to just keep up with how many times a query is ran, identify what your top queries are as far as your CPU, reads, writes, duration, and a few other metrics. And it also keeps you an audit history of all your query plans. So you can go back and you can see that you've had 10 different query plans for this one store procedure or this one query. So it gives you an idea of how much stuff is changing over time. And it also allows you to see the usage patterns of your particular database. We find this very useful for when we're deploying our new app. We're in an Agile shop, so we deploy on the second Tuesday of the month a new version of our application, so we're able to go in and look at the databases and see a sudden spike in CPUs across the servers, and if it corresponds to that Tuesday, we know that something happened during that release, and we're able to go in and drill down and pinpoint a particular procedure that may be causing that problem, whether it's something new or something old or just something that needs a new index. And these are the type of things that it makes it easy for you to be able to see. Now in 2017, they've added a couple of new features which are really cool, I think. One is you're able to see your weight stats for each query. I'll explain more what that means because it's not individual weight stats. Those are by categories. They've summed those up into 23 different categories because storing every single individual weight stat for every query would just take up a tremendous amount of space. And they also implemented the ability to have auto plan correction. So instead of you going in and pushing the button to say, hey, fix this plan and always run this plan, it will do it for you. And it has a calculation that it uses to determine that. And hopefully my demo will work for that. It works 80% of the time. So preview of that to come. I got it from Joseph Sack, and he has the same ratio rate of getting it to work. So.
Tracy?
Yes.
Quick question. How much of the query store works for SQL Azure or Azure VM?
Well, Azure VM is going to work the same because you're just running a VM. They have Query Store built into SQL Azure already. They actually had like auto plan correction turned on, even though you didn't, even though you weren't actually running 2017 yet. They actually had the auto plan correction turned on behind the scenes before they made Azure 2017. So.
Got it.
So they're testing out new features in SQL Azure without us knowing it.
Got it. Okay, thank you.
And that was one of the features they were testing out. So as part of what Query Store can do for us, the easiest thing to do is to just run this command to turn it on. But as always, there are options that you might want to check before just turning it on because some of the defaults aren't that great. So the first option is your operation mode, which will be read only or write. And there is an error mode that's usually bad. You can't actually set that. By default, it does go into write mode, so you don't have to worry about that. Your data flush interval, it tells it how often to flush that data to disk because it's actually saving it in memory LOTP. So you're using Hekaton behind the scenes, even though you're not actually turning it on, which is quite interesting. And that is set up to flush the disk every 15 minutes. If you do set that lower, I've done it on my test machine, it will become the top consuming query on your machine, so I do not recommend changing that. Your statistics collection interval tells it how often to roll up your statistics into the data. So by default, that is 60 minutes. So by default, whenever you run a query for each store procedure, it stores that data in 60-minute roll-ups. So for every hour, you get one row for every store procedure or query that's been running. Your max size is one of the most important ones to change because the max size is set to 100 megs, and that is very small. I recommend 2 gigabytes, and we happen to have Erin Salato do a presentation for our user group, and she recommended 2 gigs as well.
Tracy?
There's a question, yeah.
Yes. Go ahead, attendant.
It's not specific to a version, but it has to be 2016 or above. So, your query store capture mode is by default is set to auto, so that means it'll throw away trivial plans. So if anything that it thinks are really small and doesn't really consume resources, it'll throw it away. We like to set this to all, that way we capture everything. That way, if there's a situation where we're getting something that's really small, it's just coming in and out really quick, and you're getting that death by 1,000 cuts type situation happening, we're actually capturing it. And the size-based cleanup is set to auto. You'll want to leave that on. That way, if it hits that 2 gigabyte limit that hopefully you set, you won't, if you get to the 2 gigabyte and you don't have it automatically cleaning up, it will put it into read-only mode. And you might be like me and be in a class somewhere and be really bored and want to play with Query Store for the first time and find you're in read-only mode because you was only at 100 megs. That was my first experience with Query Store. I went to go play with it, and the data was in read-only, and it was like, oh man, this data is like 2 weeks old. So then it was like, oh, we got to change some stuff. So that was back before they changed the defaults to let it auto clean up. So the state query threshold is set to 367 days. So I guess they wanted to take in consideration a leap year in a day. That's my joke for that, because I don't know where you come up with 367. But that just tells it how long to keep the query plans in your database. So you can keep your query plans in there for a whole year or longer if you want to, or you can tell it you only want to keep the query plans that have executed in the last 60 days. So you can run this in any database compatibility mode that you need to run it in. We're actually going to cover one of the usage scenarios for this is using it for upgrades and tracking plan regressions because of upgrades in compatibility mode. Answers that question. So by default, the query store is in the primary file group. So that's one reason we recommend a small size. But it needs to, yes, it does need to be at least 2016, but you can still have it set backwards to like the compatibility mode can still be set to the 2012 or 2014. But you still got to be running on a 2016 instance. So I need to change the slide because they moved everything over to user voice. But I need to see if we set up a user voice for this. I'll check Erin's thing because I'm pretty sure she put this one in there. But by default, the query store is on the primary file group, which is one reason we recommend setting it to a low size like 2 gigabytes, because you have to restore that primary file group before you can restore your other file groups if you have separate file groups and you do piecemeal restores. So if you wanted to keep a large amount of data, this would affect your recovery times, and you wouldn't be able to do those piecemeal restores as quickly if you wanted to keep a really big amount of data in your query store. So especially now that they've added wait stats. So I will try to get an updated link there for you guys if you guys like to upvote on different things that the community likes. Does enabling query store take? No, it does not take the database offline. So you should be safe there. You can do it while the database is online. No problems there. 2 trace flags that you might want to be aware of, just in case you see some wait stats or see some things happening on your system, is 7745. It forces the query store to not flush that 15 minutes worth of data that it's holding in in-memory hekaton to disk when it shuts down. Otherwise, when you shut down the server, it is sitting there flushing all that 15 minutes worth of data down to disk. We do not have this turned on, and I have a server with 500 databases on it, so it's a as you need it type thing. Other thing is when it's starting up, you may need to tell it to asynchronously load your query store. That way not everything's loading all at the same time and preventing things from coming online as quickly. And that would be your trace flag 7752. We have seen this on a couple of systems, but we still haven't enabled a trace flag because it hasn't been that serious of a problem. But those are there for your information, just in case you run across some problems and notice some slowness, and you can trace it back to this. So my request for query store is, I don't like that it's per database. I like it. I would like for it to be a central repository on the server, because as I mentioned, you can see my blurred out picture over here, that I have a server with 500 databases on there, and sometimes it's hard for me to figure out which database is on fire by that. So I'm requesting Microsoft make us a central repository for all the query store to go to. Then we don't have to worry about our piecemeal restores and everything being in the primary file group. I don't know if that'll ever happen, but I've talked to the SQL Cat team about it. We shall see. I know the open source product that people have made is a central repository, so we'll take a look at how you set things up and what options there are. Is it the case is bound to log operations? When does it take effect? It pretty much takes effect as soon as you enable it, and it starts logging all the data into memory and then flushes it every 15 minutes. Yeah, that's probably why it's bound to the database, and there are restrictions on Query Store right now, and that's probably why it won't change to like, they even tell you not to rename your database if you turn on Query Store. I will get to that in best practices. They've got some interesting restrictions around it. So if you right click on your database, you can go to your properties, and then you'll have a Query Store tab if you're running a new 2016 or 2017. And you can see Query Store is already turned on here. So I can easily just turn it off and everything will be off. So you can turn it on just by doing that, and you'll see that it does the defaults of 15 minutes. I've got my statistics interval set to 5 minutes just so it collects things differently on my machine. And I've only set mine to a gig on mine, and I've changed this to 31. So, but that's all you gotta do to turn it on, or you can run a query to turn it on and set up the options. They do have a button down at the bottom. I'm assuming everybody's remote, so I don't need to use Zoom it, do I? If nobody says I do, I won't. They have a button down here. If you wanted to, you could purge the data out. So if you needed to reset for some reason in a test environment, and you wanted to reset all the data and rerun a test for some reason and didn't need the data, you could purge all the data out and, you know, reset to a certain, you know, empty state. And sometimes when you go in here, whenever we've had the data, we've noticed the Query Store in an error mode, we've had to use the purge in order to get it back into a read-write mode. So just kind of informational message there. But that's really all you gotta do to turn it on. And once it's turned on, it starts capturing data. We're going to get to that question next. Well, almost next, after we cover some other stuff. But we will cover what data it captures. First, we're going to cover how it works. So first you execute a query, then it looks it up in the plan cache, and then it decides if it needs to compile or optimize this query. And once it decides that, it goes and it looks in Query Store and sees if there's a forced plan or not. And if there's a forced plan, it goes and gets that plan instead of doing a compile and an optimization, and then it skips over that process and executes that forced plan instead. Otherwise, it goes through its normal processes and fetches it from the plan cache and goes back through, checks to see if it needs to be recompiled, and executes it, and then it finishes it. The best part is a little gray line where it sends all the execution stats into Query Store. And then you have all those execution stats to troubleshoot your system with. Now we'll go over some usage scenarios, and then we'll get into some reports where you can see what data it's collecting. So we talked about regressed queries. So again, this is kind of where a situation where you have some parameter sniffing. You can identify all your queries with the execution metrics that are degraded in a certain period of time that is of interest to you. So we've taken situations where we've upgraded our systems on our second Tuesday of the month, and we've seen degradation in a particular stored procedure because someone changed the index. I've had instances where on Christmas Eve, I call him Mr. eBay. I work for an e-commerce company that pushes stuff out to Amazon and eBay. So Mr. eBay, he paged me about a particular database, and I was able to immediately log in and see where this plan was sitting up here and this plan was down here, and I was able to force the plan using the GUI, much to my boss's dismay that I used the GUI. But it was Christmas Eve. But I was able to go in there, and because this query had regressed in its plan, and just force that plan and say, hey, you can use this plan instead. So you're able to do that very easily by going in there and seeing what plan it's choosing to use is bad, and choose which one's better from its previous history, because you can see the history of which plans it's used before and what stats it's used. This is an example of a report that Microsoft will give you and that shows you regress plans. So they just ran one query, then ran a bad one, ran a good one, ran a bad one. The check marks indicate that they forced the plan. So at some point they decided that the pink one down at the bottom was the good plan, and the brown one was the one that they didn't want to run anymore. This is what one looks like on my system. I like the green one because it's running at 0, whereas the pink one sometimes runs at 6 million, and that's CPU. So we ended up forcing the green plan in this scenario. So that's just a quick example. We'll actually drill down and look at the actual reports and get away from print screens here in a little bit. So one of the things you can do is you can check the status of force plans. I left this query in here, but as of the Studio Manager for 2017, they finally put a report into 2017, so you can see force queries. They used to not have a report in there. And I've worked for shops that used to not let you upgrade your Studio Manager. So just in case you need a query, here's the query for it. But now you do have the ability to check the status of force plans. Force plans can fail. They can fail for different reasons. One could be that an index in that plan got dropped or recreated. So if that happens, you need to know. One of the best ways to track this really is via an extended event, because then you can track it server-wide rather than tracking it per database. If you only have one database, then you can track it very easily this way, but if you have 4 or 5 databases on the same server, it becomes a little bit more trickier to track. But there is an extended event that only works in 2017 for that, so you have to kind of, depends on what version you're running on how you're going to be able to go about tracking when your force queries are failing. This is an example from our live system when we implemented Query Store back in 2016, and we evidently we rolled out some code around the 24th of August, which is not a normal release. So somebody rolled out something, did a hot roll, and we see at the top our duration, our execution counts. Actually, our execution counts went up, but our duration stayed, on average about the same. And our CPU actually dropped, and our logical reads just went to the floor. So if we wanted to, we could have drilled down in there and tried to figure out why that happened and why things were running. We were running more, but doing less work. So it seemed kind of odd. But this is what an overall resource consumption report would look like if you looked at it over a 30-day period. So that top consuming resources is one way where you can look at forcing plan regressions, because you can drill down on there and see what's running per that day, and it'll show you each and every query. And in there, it's just like being in Studio Manager. Once you see a plan, it'll show you your missing index hints. Now, we all know we don't just go and create every missing index hint that there is, but it does give you a hint that you can use to try to figure out better ways to do things. Sometimes it's just as simple as updating your stats to make a better plan. Sometimes you need to just make sure your indexes aren't defragged. Still the old school methods of fixing things. And the other thing you can consider when you got a really bad query is rewriting it so it's not as expensive as it used to be. So those are your top 5 things you're going to want to look at when you see a query that's consuming a lot of resources on your servers. Write down a list, the easiest way to fix things, and then the hardest way, of course, is to rewrite it. So this is a new report they added in a newer version of Studio Manager. I keep calling it Studio Manager. I've worked on SQL Server too long. Studio Management, the SSMS. So queries with high variation are when queries have the same plan, but they vary very highly in how they execute. So this particular query didn't vary very highly. I couldn't find one that was very highly varying on my system at the time I was looking, but I wanted an example in my presentation. So it only varies from 5 to 35 on duration on milliseconds, which isn't too bad, but you could have something that varies very widely, and you might need to try to figure out what's going on even though there's not a different plan. So those are situations where you're probably going to be looking at indexes or rewriting the query because something weird's going on there. So now we'll actually go in and drill down on the report so you guys can see what some of this stuff actually looks like live. So I've been running a workload on my AdventureWorks database, and we'll kill it so my server will run a little bit faster. I said run faster. There we go. So I've been running some stuff today, and last week I ran some stuff getting ready for this presentation. So this is the overall consuming report that we've seen earlier. You do have the ability to see this in a grid format. So you can just see the data in that format, and it gives you the ability to sort. So if you wanted to see which day was the top memory and say, okay, that's the one I need to go look at, you could use that method as well. That doesn't give you the ability to drill down like the chart does, but if you're in the chart and you got one in particular that you want to look at, when you drill down, it takes you to the next report. Which is your top resource consuming report. And from there, you're going to see this really gnarly looking query that has all kinds of stuff it's doing, all kinds of compute scalars and steam aggregates, and just because it's doing a lot of summing and going into sales order details and stuff, and it's varying all over the place on its execution, and it only has one plan. But this is our query that we will want to improve on, because it's the one that's eating up the most resources on the machine if we wanted to do anything with it. Again, we also have the ability to go in and look at the grid, and you can see what store procedure name it is, and it will show you the selection of the text and the duration for that. Up here, you've also got the ability to do it by different data, so you can do it by execution count, your reads, your writes, your CPU. They even added DOP and memory consumption. You can do it by row count, temp GB, and now they have the wait time in there. So that's something that's only available in 2017. So you can change all that data around and see, you know, which one runs the most. So that's the one I want to look at. So, and you can view this side in grid format as well if you had multiple plans. We will get back to showing forced plans and tracked plans when we actually force a plan later. So as far as variation, we don't have many that vary very highly because we're running the same store procedure basically with the same parameters, because I'm running a very generic workload. So on AdventureWorks, so it doesn't vary that much. But if you did see some high variations, it would tell you that there was something there that you needed to look at on that particular day and that you might need to drill down in on and take a look at.
Tracy?
Yes.
Some of this data is also found in extended events, or this is completely brand new?
No, this is all brand new in Query Store.
Got it.
It's not in extended events.
Got it, thank you.
Sorry. So those are the basics of those three reports. Like I said, we'll look at forced plans and tracked queries when we do when we actually force a plan, which we will do after we cover some different usage scenarios. So I do have some demos coming up. So I tried to group all my demos together because I got a lot of complaints that I had too many demos spread out throughout things. So I tried to keep things grouped a little bit together. So people were complaining I went in and out of slides too many times. So your different usage scenarios for this can be your A/B testing. So if you're rolling out a new application version like we do when we roll out a new release every Tuesday or every second Tuesday. If you're adding new hardware to your server, so if you're changing your CPUs or adding memory or any of those type of things that might affect performance. If you're adding new indexes and you want to see what happens to those queries. If you want to identify and improve any ad hoc workloads, you can go in there and see what ad hoc queries are running and try to turn those into store procedures. Another good usage scenario for this is for when you're upgrading. So if you want to upgrade to 2016 or just skip on ahead to 2017, so you can have wait stats. You can leave it in your compatibility mode that you had before in 2012 or 2014. Hopefully you're not in anything lower than that, but you might be. You can leave it in whatever compatibility mode you had. And you can enable Query Store and go ahead and start capturing plans. Would it capture dynamic SQL? Yes. It'll capture dynamic SQL as well. But you can capture all your Query Store plans running on your old compatibility mode. Then you can set your compatibility mode up to 2016 or 2017, depending on which version you're running, and see if any plans regress because of the new changes in the engine. And if they do, you can just force those plans until you're able to figure out a better fix. It's not like the old days where you had to send the whole database back to its old compatibility mode. Now you can just fix those 1 or 2 queries. No, there's not a limit on the plans per query. It's just a limit on the space. So whatever it can fit in at 2 gigs based on the parameters you set when you set it up is its limit. So this is an example of what you could use to do ad hoc workloads. So if you go in and change it to execution count, you can scroll over and find all the ones that have only executed 1 time, or change it to that grid mode and see which ones have sorted and executed only 1 time, and see if those queries are the same. And if they're the same, you probably want to change them into a stored procedure so you're not bloating up your query store with a bunch of ad hoc workload. There's also a query in Books Online that'll clean out your ad hoc workload from Query Store so Query Store doesn't get bloated, because if you're getting a lot of ad hoc stuff, then you're just filling up Query Store with a lot of unnecessary stuff if you're not grouping things together. And that's just there to explain my other slide. So your summary of your usage scenarios are: you can use it to pinpoint and fix any queries that have regressed in the performance, identify and tune any of your top consuming resource queries. You can do it for your A/B testing on your new versions of SQL, your new versions of your apps, adding indexes or hardware, and you can keep the performance stable whenever you want to upgrade your SQL servers up to 2016 or 2017, and you can use it to identify and improve your ad hoc workloads. So, any questions now? So new in 2017, we've added wait stats, which I think is one of the coolest things that could have added to Query Store, because what do we use to troubleshoot everything with? Wait stats, or at least I do. So basically they added a new DMV called Query Store Wait Stats. They couldn't have made it any simpler for us to figure out what it was, could they? But it tracks all your Query Store wait stats into categories such as just CPU and memory. It doesn't track each individual one, because that would take up a lot of individual space. So it currently just has 23 categories that are all documented on Books Online, and you can see where everything is categorized into those ones. If you need to know which specific ones they put into which categories, you can go on Books Online and see which ones went where. The other new feature in 2017, which is pretty awesome, is the auto plan regression. So now, if you're not a trusting DBA, you can turn it on and tell it to just record recommendations. So say you don't want it to force plans for you, you just want it on and collecting data. So you can turn it on and just say, hey, just collect me some data, and I will force the plans by going in and looking at the recommendations. So the recommendations will surface up in your recommendations DMV. And this is a command to turn it on. And then you can, and the best part about this is once it forces, if you let it force a plan, if it forces a plan and later on that plan is no longer a good plan and a different plan becomes the better plan, it will unforce that plan and force a different plan. So it kind of just goes behind the scenes and just keeps taking care of things for you. So the data is in the DMV even if you don't have, like I said, if you don't have the option turned on. So you can go in there and see what's going on and decide if you want it to force the plans automatically for you or not. Yes, it does increase the temp DV activity. We are currently opening a Microsoft support ticket because it increases our TempDB activity very badly, but we run over 30,000 transactions per second on our database system. So, and I know of one other speaker who's having the same issue with his TempDB in Query Store. So, if you have a big TempDB activity, you may want to test it out before you turn it on a system that's very active. Just a warning from 2 people that I've seen with the problem. I've spoken to probably at least 1,000 people by now that are running it that don't have any issues at all with running Query Store and their TempDB. But my personal experience, we've had a few issues, and I know of at least one other person that has. So definitely run it on your test systems first. And if you see any TempDB issues once you do it, I would turn it off. What you will notice is page latch contention. How does this work for queries that use more CPU cores like multi-threading? It just counts up the weights based on that. It determines how long it bases it off how long it takes to run the query based on the plan. And if it can determine that a plan will be faster, it's always based on whether the plan will be faster or not. And if it's 10% faster, it will automatically do the plan regression. Does that make sense? Now we got a whole bunch of demos. That way we can actually see this thing work. I got slides on in-memory optimized tables coming up as well. They do work, but there's special circumstances on making them work. Let me turn off my flux that's making my screen orange and yellow. Where's flux at? Sorry, guys. There we go, bright screen again. It wants to make sure I don't have too much blue light. So, bring up my PowerPoint so I can remember which demos to do. Okay, the first thing we want to do is we want to look at forcing a plan, because that's the whole point of Query Store, is being able to force a plan. And where I have this, I got to rename because I switched to a different machine. Sorry, I set up a new VM this week, so that should be the only place I got to change it for now. So I got the script from Slava, and I can't say his last name, but he's out of Baltimore. So we're going to turn off Query Store and turn it back on, just to make sure we have everything set the same. We're going to use our EventualWorks database, and I'm just going to clean up stuff just in case I had stuff there already. We're going to recreate this index if it was there and delete this data if it was already there. I don't think it was, because this is a new machine. Ooh. It doesn't even exist? Really? Did I not highlight the use statement? Oh, I didn't highlight the use statement. So, turn on our show execution plan. So, we're going to create a state out for this last name of Martin for the month of July of 2014. Yes, we have an old database. Good old EventualWorks. And we're going to get nothing, which is totally expected. But what we're going to mainly be concentrating on is what our execution plan looks like. So we've got a non-clustered index seek, and a RID lookup, and a table scan, and a nested loop, and a hash match. And we're going to have to try to figure out if this is the execution plan we actually want to keep later. So now we're actually going to get some data. so we can see what it does when it actually has some data. So what we're going to do is we're going to copy all of June's data and make it July's data. So we're just going to add a month to it. That way when we run the query, we'll actually have some data to look at. That way we'll have changed something in the database to make us have a different execution plan. So now we've got the same execution plan, and we're running in about 3 seconds. And it seems pretty expensive for 3 seconds for it to return. It's doing a lot of reads, doing 3,000 reads, and might be a little small even for the monitors, but that's 3,000 reads there. So we're going to update the statistics and see if we can get us a better execution plan. Now that one took a second. And look at that, we're only doing a table scan, and we're getting everything back with a hash match. Much faster plan. So now let's go see what that actually looks like in AdventureWorks. So we should have one query in here. No. There goes our query. So we have a query in here that's got 2 different varying plans, and we see we've got the 2 different dots, one at the top and one down at the bottom. So we're going to take this plan and we're going to say we want to force it. So when you highlight that one, you can hit force plan and say yes. And forever and for more, unless you drop an index, it's going to run that plan. There's also the ability in here to compare plans. So if you highlight 2 of them, you can actually click the button up here and it will compare the 2 plans for you, so you can see what the difference is between them and decide if what you want to do with them. So that's a neat feature that they added in a later version of SSMS. So it wasn't in, I think that got in 17.4, if I'm not mistaken. So now that we know this plan ID and this query ID, we can take a look at queries with forced plans, because we couldn't look at that report before because we didn't have any forced plans. So now we can see we've got a query with a forced plan and what the two plan IDs are that we had. So over time, you could take a look at this and go, hey, maybe this blue moves up to the top and the gray, the gray starts looking normal, and you decide that you don't want to force it anymore, and you could click on it and unforce it. Now with 2017, you would have it turned on, hopefully, to do it all on your own. Yes, all the scripts will be available on my website so that you can run this. So, and then if you wanted to track this particular query, the query ID is given here. So if you wanted to write this down and remember it later for some reason, or any query for that matter that you pull out of one of these reports, you can pull it up and see what it does over time. And that's just kind of how those extra reports work that we didn't look at before. And that's the basics of how you would go about forcing a plan. And that's basically what I did on Christmas Eve. Is I came in here and I seen a whole bunch of stuff lined up at the bottom, and then I seen stuff way up here up at the top. And I just took what was at the bottom and I forced it, and I went about my day, and it took me 10 minutes to save Christmas Eve. That's the way I worded it anyways, because it saved my Christmas Eve because I was the one on call. So, not that PowerShell. I don't have a shortcut for PowerShell ISC down there. Now, one thing that, as I told you, I have databases or servers where I have multiple databases. So I like to query across multiple databases. So I wrote a PowerShell function that will actually do that for you. Does the force plan a particular color? No, they just pick random colors. I don't know where they get their colors from. And they just they just stay whatever color they are. I don't know how they pick their colors. It's just Microsoft being colorful, I think. Different queries will have different colors. But I wrote this function that'll let you query across multiple databases. And you can basically send in, I probably should add some stuff on here because they've added some new stuff, but I can do that later. But you can send in the execution duration, CPU reads, writes, memory, or row counts, and tell it to get the top 5 queries per database in the last 2 hours that executed a minimum of 10 times or something like that. And I've got different queries in here for the different things, and it'll output it to a grid. And I got an example right here. And I don't have PowerShell loaded on this machine. That's a bummer. But I do have another virtual where I can show that. So I came prepared for if I didn't load something on that machine. I didn't want you guys to miss out because I loaded up a new machine. And there we've got stuff that's ran across my VentureWorks workload database on this particular server, and it would have pulled across multiple databases if I ran across multiple databases. And then you can sort and query and figure out which ones were your high CPU during that particular time. I pulled out the top 10. So if you had multiple databases, you could go in there and figure out which particular database was your problem. We don't need that VM right now. So as we mentioned, they added the DMV for wait stats. I wrote a very basic query for the DMV for wait stats because I'm going to show you Brent Ozar's script, which is much better than mine. But I wrote mine basically just so you could see the different categories that I could produce on my machine. But as you can see, they've narrowed down the categories to a very specific set of data. I've only managed to produce 15 of them, and they even have an unknown. So, but buffer IO seems to be a popular one on mine. CPU usually is high on mine as well, and CPU's on there. But if you query the whole DMV, you can get them all. You can join these back to the plans and figure out which ones they were by a particular time. But there is a much better way to do that. So we will take a look at that in just a minute. One thing I did write was this for Ops Studio. I have a blog post that tells you how to set up this in Ops Studio if you haven't played with Ops Studio yet. This is kind of a neat way to look at wait stats per database. This just sums it up for a database, so you can tell parallelism is the #1 thing on my system. I'm only running 2 CPUs on there, and the other one's idle CPU and disk. So those are the big things that are running on my system that are causing me problems. I don't have my max stop set, so everything is probably running both cores on my system, probably why it's running parallelism on mine. Probably if I changed my max stop to 1 and reran this workload, that would probably go back down, and CPU would probably take over as being the #1. But I do have a blog article that lets you run this query, and it just shows you what's been happening over the last hour on the system, and it shows you how to turn it into a graph and save it so that every time you bring up and manage a particular database, it will show you the that graph for that database. So that database has a different graph And worldwide importers would have a different one if we ran something against it. Okay. Now on to auto tuning. Now this is a demo I mentioned earlier. It's a really cool demo, but it only works like 80% of the time. So I got this demo from Joe Sack, but basically we use worldwide importers for this demo. And we just insert one record, and we're able to, and we create a column store index, and we're going to create a procedure that does some stuff, a couple of procedures that cause some regression and turn on auto tuning and turn it off. And this is all we need to be able to demonstrate some regression going on in the system. So if you have an empty worldwide importers database, you'll be able to get this script and run it and show how auto tuning works. So I'm going to initialize that database for our demo. Of course, I have to put it in the database first. I don't have a use statement up there. Just adding one row just regresses it, which just fascinates me when he told me that. Now we're just going to clean everything up in that database, because we're good at following directions. We're going to turn on our show execution plans with our Control M. And you've got to run this so many times for it to capture a baseline. So the recommended amount of times is at least 60. And sometimes it can be more depending on how big your server is. And I found 60 seems to work on mine. But the main thing we want to point out in here is that we have a hash match aggregate in here with a column store index scan. And we're going to try to change this plan to something different after we let it run 60 times. I don't know if anybody's ever seen the go with a number behind it before, but if you put the number behind the number go, it'll run whatever's in that batch that number of times. It's kind of a cool trick I learned a few years ago. While we wait for that to run, we can bring up the next script if we want to, so I don't want to keep everybody up late. Okay, Brent Ozars wrote, one of his companies wrote a SP Blitz query store procedure that can pull back some data for you as far as your weight stats go. If it's 2017, it'll pull back weight stats for you. If it's not, it will skip that, of course. And you can put in different parameters. One is if it's in debug mode, it can pull the top procedure for you. It can do it based on a date. You can do it based on an end date, based on a begin and an end date, a minimum execution count, duration has to be a certain number of milliseconds. I don't know why he puts an example of a store procedure that doesn't exist in there, but he has that in there. You have an example of a database that does exist, and you can look for failed queries. I'm just going to run the last two. Because of how Microsoft indexes query store, sometimes that takes a while to run. And we got to be in the right database for that too, I think. So it should have ran. Well, of course, they couldn't find my store procedure. Darn nabbit. I'll find a store procedure I can find. We'll come back to that one. We'll concentrate on one thing at a time. Back to regressing queries. It ran 60 times and it took a minute to run. So we're going to try to get this to run faster. So we're just going to run this one time, but we're going to reset the scope of by clearing the procedure cache in this database. And it's going to run really fast, and it's got a Steam aggregate with the index scan and no nested loops. Then we're going to run the same workload that we ran before, the same one from before, and we're just going to run it 20 times because this established a new baseline. Just by running it one time, it got a new query plan. So now we're going to get a different query. We're going to run it with the same query plan from before, and it's going to go, aha, I'm going to find something different. And we only need to run it 20 times for it to say, hey, I need to make some recommendations to you about what you're doing. Now, unfortunately for us, we haven't learned XML yet. I haven't anyways. Now we got to learn JSON. But JOSAT gave us a query, so we're good. So based on the recommendations in the tuning wizard, if we were to force this plan, it would go from averaging 202 milliseconds to 14 milliseconds. And they were kind enough to give us the script to just copy and paste out and force that plan. Now, if you want to see more details, which I like more details, so we're going to see more details. It'll actually tell you the plan, the estimated gain, which when you have autocorrection turned on, that estimated gain has to be above 10% or it will not autocorrect. And it'll tell you if it's error prone, which I do not know what the definition of that is yet. Nobody has explained that to me yet. But that's basically it, and it gives you a score of, hey, this is, you know, a high chance this is going to help you if you turn it on and let it go. So if we wanted to force that plan, we could just copy the script and it would force that plan. And we're not going to force it because we're going to let the auto plan cache turn it on for us. So we're going to enable auto tuning on. Does the query store give wrong stats or numbers? No, it records the actual execution stats that are returned from when you execute the query. So now that we've got that turned on, we will verify that it's on. So that's always a good thing to do. Okie dokie, we're all good. Now we're going to run our same regress workload 60 times like before. So it'll take us a minute. Give or take. Any other questions while that's running? Oh, bad execution plan, I meant. If you got a bad execution plan, just one that's not good, it's just going to give you what stats it took to run that bad plan. It's not going to give you bad stats, but if you got a bad plan, you're still going to see it. So we have a little square there. That means it stopped running in the middle. So that means I turned off my machine, basically. So just in case you ever see that and you're wondering what that means, I'm going to come in here and get a procedure name for Brent's procedure while that was running. That looks good enough. Okay, it's on the clipboard. So that's ran 60 times. It took a minute again this time. We're going to clear out the procedure cache and run our one that gives us a good execution plan. It runs faster. Then we're going to run this 20 times. Then we're going to check for our recommendations again and see if it forced it. because it should have, because last time it said it would increase it by 13%. And it says it's not enabled, and we checked to see if it was enabled, and it was enabled. We did that. That was a bummer. Oh, we gotta wait another minute while that's running. All VentureWorks, this one did return my query for me. Blue flowers, blue flowers, blue flowers. Brent writes some weird stuff, doesn't he? Anyway, we got back our store procedure that we put in for Brent's query, and it's telling us, it gives us this execution plan. He gives us some warnings about our plans. He's telling us what we're waiting on. He tells us if we have parameter sniffing problems. He tells us if it's forced and if it's failed. He gives us our top 3 weights, which is kind of cool to have, so you can quickly see those. And he gives you all your stats, basically over that time period that you put in for, which we did not specify one, so. And then he explains what each one of these things means down here as far as what he's warning you about. So I like to use Brent's query, especially when I'm looking for a particular store procedure or just trying to diagnose something really quick, because he gives you some warnings against your query plans, just like he does with his other queries. Let's see if we can get this to force. If we can't, we will move on. Like I said, it has an 80% success ratio. It's still saying it's not turned on. It still ran fast though, so maybe it did turn it on and I'm not understanding the output. Maybe it was on and I didn't get it. Recommended plan is 2, new plan ID is 6. Yeah. It's running fast, so I can't tell if it forced it or not. I guess we can look in our top consuming queries and see if we got any forced plans. Nope, no forced plans. Nope, and it didn't force it, and we got 2 different plans. But it's supposed to force that plan, but it did not. I don't understand why it's not working tonight. Sorry about that, guys. But that's all my demos. Back to slides. So they added over 50 extended events. Lots of them mean nothing. They're mostly for debugging and to make your system go really slow if you're going to be debugging. So the regression one was there in 2016 but did not work. So do not try to use it in 2016 in hopes of catching queries that are regressing because it will not work. Trust me, I tried. So, but that's if you want to catch your queries that are regressing and you want to trigger something and see across the whole server. If your queries are regressing, you can capture that and then send yourself a report or query it out and see it rather than having to go into each individual database to see what's regressing. The other thing you want to flag is if your query store goes into a rewrite failed state. So if it goes into an error state, you don't want to have to create each individual database to find that out. So you might want to extend an event session set up for that you query every so often and fire off an alert about that. The other important one that I find is for when the query store plan that's forced is failing, because that means every time it's going into query store, fetching it, filling it, and then compiling and running. So that's just extra steps it's taking. So I mean, it's going to run something, but you're taking that extra step of going and finding a plan that it can't use, and that's wasting CPU cycles and time on your server. So you might want something set up that's telling you that that's happening, because you just never know when your developers might roll out new code and you just don't know that an index has been dropped or not. And they might not know that you forced a plan that's causing problems. So on to some best practices. Manage the size, keep it kind of small because you're in that primary file group, or big if you don't have to worry about piecemeal restores. Set your statistics interval to something that means something to you. We're at the 60-minute mark, but we have been down to 15 minutes before. Right now we're trying out 60 minutes because of our tempDB issues, and that didn't seem to help, so we don't think that's the cause of it. Make sure it's continuing to collect data. Make sure it stays in the read-write state at all times. CPU requirements. They say it takes about 2 to 5% CPU utilization on your system to add query store. And that's going to vary depending on how much workload you have on your system and how much of it's ad hoc as well. They say avoid using the non-parameterized queries, avoid ad hoc workloads, because that just bloats up your query store. If you can't avoid ad hoc stuff because you have vendor software or something like that, there is a procedure online to help you delete that out of your query store to avoid that bloat. Avoid using the drop create process for store procedures, because that drops and creates your IDs, so that uncouples the plans in the query store. So if you drop and create procedures, then it creates a whole new ID for the procedures, and then anything that you had forced is it's erased. It's gone, and it doesn't group the query plans back together. So you're going to have a whole nother set somewhere else. Use Alter when you're changing your store procedures. And they also say to avoid renaming your databases. I don't know why, but that's what they say in the best online. So back to the in-memory question. So they do collect statistics for your in-memory objects. You have to use a special store procedure to tell it to do this. Issues with this is every time you restart your server, you have to tell it to collect on these objects again. So you're going to have to write a startup store procedure to say, hey, I want to collect these statistics again. Yes, you would get it with you would get a new plan, but if you change the store procedure by doing drop create, not only do you get a new plan, but you don't get it grouped with your old plans, is what I'm saying. So if you had 2 plans before with the old object ID, and now you have a new object ID, you got 1 plan instead of having 3 together. So you can't see the changes if you do the drop create. If you clear out your query store, you must turn on the query store collection again. So you're in the same boat if you restart your server. There is a field that tells you if a query plan is in-memory OLTP, and also it does not keep up with memory grants, because who would want to keep up with how much memory is being used if you're using in-memory OLTP? Not me. No, not me. But maybe you, but not me. No, I'm just kidding. I would, but they don't want you to. But that's pretty much the end of the presentation. I've got a couple of resource slides on here for where I've got most of this information from. There goes my workload generator that I borrowed from Bradley Balls, and I've got one from Brent Ozar for Stack Overflow that I didn't use on here. where I got all the tuning demos at, where to get Brent's procedure, and the couple of things that I wrote as well. Any other questions?
Yes, there is a question about the backup. If you can back up the query store.
It is backed up with the database. You can actually back up your database and drop all your tables and send it off to a consultant, and they can troubleshoot your stuff for you without your data. They would just have your query plans and your stuff. So I've heard of people doing that. DBC clone database will actually clone databases with your query store in it, or without it, depending on which way you write the command. So, but yeah, it's part of your primary file group, so it's backed up with your database. So, like I said, the easiest way to reach me is just, to remember anyways, is databasesuperhero.com, because Boggiano is hard to spell. That's what I always say. But if you got any more questions or anything else that pops up that wasn't clear, just feel free to email me or hit me up on Twitter.
I don't think you are going to scare us with your last name. Difficult. Ours are much worse. Don't worry about it.
That's why I came up with a cool website to keep up with. So, it's easy to remember.
So
you're really
right?
superhero.
Trust me, I married into that name, and yeah, it's hard to spell. So, but like I said, if you guys need anything else, got any more questions, feel free to hit me up with email or Twitter, either one. So.
Okay, I have a joke because I married even in another big name. I had a bigger name than I married into, but it's much harder. So.
Well, I had Tanner before, so I just lived with Alf. If you grew up in America, you don't know who Alf is. Or I grew up in the Full House with the Tanner kids. That's how I got picked on in school, so.
That's good.
It's like they always wanted to know where Alf was. Well, I will stop sharing now, I guess. And I will email stuff. As far as other monitoring tools, yes. In combination with Query Store, we are using a combination of Telegraph and InfluxDB and Grafana to get performance metrics. I recently, no, it won't be recorded until June, but I recently wrote a blog post about exactly how to set it up. That's on my website. But I am doing it for the Database Administration Virtual Group in June. Oh, you mean this presentation recording? I thought you was talking about a monitoring presentation. Sorry, I'm confusing presentations now. I do have 5 presentations. I'm working on 2 others right now, so. Let's see.
There is a question about Query Store, if you can use Query Store to create a baseline.
Yeah, you can use it to run like a workload and see what it does for a certain period of time, and like know that during this hour you ran this particular workload, and then run it during another hour and compare it. Some It's not that great for drilling down because it rolls the data up into the hour-long interval or the 15-minute interval. But it can be used that way. It's just a matter of how you set it up and how you time it.
The question is about availability of Query Store on Linux.
Yep, Query Store is available on Linux.
What about the MDW?
MDW, I don't recall it collecting queries. It was more for collecting performance metrics. I mean, more like, you know, CPU usage, memory usage and stuff like that. We've completely switched to using a combination of Query Store, SP who is active for stuff that's running currently, and the Telegraph solution at my shop, which is the Telegraph is all open source. It's my newest, greatest presentation, if I do say so myself. So I've only done it twice, so it might not be the greatest. It's just the newest. I am trying to get that one into pass this year, the Telegraph one. Hopefully they will accept it. I think it would be a cool open source thing for people to monitor with. Ops Studio. That's a new cross-platform management tool that Microsoft released for to kind of replace SSMS, because SSMS will not be available on Linux or Mac.
I'm sorry, which one is the tool that's not available on Mac?
Well, SSMS isn't going to be on the Mac, so they got the SQL Operations Studio now.
Does it have a version for my students? Some of them use Macs.
Well, they're open sourcing it a little bit on Microsoft's side, the Operations Studio, and working on it. So I believe it runs on Mac and on Linux, because they're trying to do more cross-platform stuff.
Mm-hmm.
And that's the one I wrote the graph for. So if you go, when you get my slides, if you go to the link that I put in there for adding the graph for the Studio Manager, it'll take you to where you can download it.
Oh, okay.